Hello, this is section 11.1, inference about two population proportions. So I already showed the single population proof. This is two population proportions. So we're going to have two cases. One is independent cases and the other one is dependent. So in the independent cases, the sampling method is independent when the individual selects for the one sample do not dictate which individuals are to be in second sample. A sample method is dependent. When the individual selected to be one sample are used to determine the individual to be a second sample. So dependent sample are often referred to the matched pair samples. It is possible for an individual to be matched against him or herself. Okay, so number one, distinguish between the independent or dependent sample. So for each of the following, determine whether the sampling method is independent or dependent. A researcher wants to know whether the price of one night stay at a Holiday Inn Express is less than the price is a one night stay at the Red Roof Inn. She randomly selected a town where the location of the hotels is close to each other, and to determine the price is one night stay. So I think the keyword in here is the location of the hotels are close to each other. So I want to say this is dependent, because if they are the close each other, I think the price will be affect each other, right? So, and then B, a researcher wants to be whether the state quarters introduced in 1999 have a mean weight that is different from the traditional quarter. He randomly selected 18 state quarter and 16 traditional quarters and compared their weight. Okay, in this case, the state quarter and the traditional quarter, I don't think they are really anything because I want to say it's independent. Okay, all right. All right, so the next page, a sampling distribution of the difference between the two proportions, independent sample. So suppose the simple random sample is a size n1 is taken from the population where x1 of the individuals have a specified characteristic, and a simple random sample size is n2 is independently taken from a different population where x2 of the individuals have a specified characteristic. The sampling distribution is p sub 1 hat minus p sub 2 hat, where p sub 1 hat is x sub 1 over n1, and the p sub 1 hat is going to be x sub 2 over n over 2. So this is what we need to remember, okay? So we have two different proportion. So approximately the normal, where the mean is the difference of the two proportion. And then standard deviation is you have to actually the square root of, and then we just put the p1 of, and then you need to get a sum of those two. So individually n1 p1 hat must be the greater equal to 10, and then n sub 2 p sub 2 hat times 1 minus p sub 2 hat also the greater equal to 10 too. So this is the intersection, so it has to be satisfied in both cases. Each sample size no more than the 5% of the population too. So sampling distribution of the difference between the two proportion. So it's standardized version of p sub 1 hat minus p sub 2 hat is written as z was, okay, this is the formulas we use for the z score as approximate the standard normal distribution. So the best point estimate p is, we are using this. And then test statistic is p sub z sub 0 is this form, which is we are using of this formulas, okay? All right, let's go to the next page. And then the best point estimate of the p is called the pool estimate of the p, denoted the p hat where is the p hat is this. And the test is the comparing the two population. We got this, which is we have this form. So hypothesis. Testing regarding the difference between the two population proportions. to test the hypothesis regarding two population proportion P and P2 can be. So has to be the sample. We have to have independently. Samples that must be independently obtained using the simple random sampling, and then we already talked about this. And then the must be the 5% of the population less than. And then step 1, we two-tail, left tail, right tail. So now in the null hypothesis, gonna be the same. It doesn't matter which one. For the alternative hypothesis is not equal to for the two-tail, less than for the left tail, and then greater than for the right tail. So P1 is the population proportion of the population 1, and P2 is the population proportion of the population 2. So, and then we do the select the level of the significance, which is alpha, that is significance of the making a type 1 error. And then classical approach, we need to find the z sub 0, which is test a statistic, which is we use this formula, and with the p hat is going to be proportion of that. And then whatever the critical value falls into the critical region, we reject our hypothesis. Okay, so this is the case of this. And then step 4, compare the critical value with the statistics. So two-tail, we use this and then reject it. And then they're actually telling you the test statistic falls into the critical region. For the p-value, you use the compute the test statistics. So g sub 0, same thing, and then we use that. And then two-tail, we're using the p-value is equal to 2 times proportion of the z greater equal to absolute value of z sub 0. And then p-value for the left tail is going to be the p sub z equal less than j sub 0. And the right tail, we are using this form. And then use the technology, you can find it too. And then step 4, p-value is less than alpha, we reject it, and then we state the conclusion as number 5. All right, so let's get to the problem. So problem number 2, we have here. All right, so economists believe that the percentage of the urban households with the internet access is greater than the percentage of the rural household with the internet access. He obtained a random sample of the 800 urban households and find that 338 of them have internet access. He also obtained a random sample of the 750 rural households and find out that 292 of them has internet access. Test the economist's claim at the alpha equal to 0.05 level of the significance. So first of all, we must verify that the 3 requirements are satisfied. So first one is the sample simple random samples that were obtained independently, which is we have to believe that it is. And number 2, x sub 1 is 338 when n sub 1 is 800 for the urban households, and also x sub 2 is 292 when n sub 2 is 750. Because of that, we can find p sub 1 hat, which is x sub 1 divided by n sub 1, which is 338 divided by 800, which is about 0.4225. And also we can find the p sub 2 hat, which is x sub 2 over n sub 2, which is 292 divided by 750. And then we got about 0.3893. So because of this, we can find the n sub 1 p sub 1 hat times 1 minus p sub 1 hat, which is 800 times 0.4225 times 1 minus 0.4225, which is equal to 195.195, which is greater equal to 10. Also, and 2 p sub 2 hat, 1 minus p sub 2 hat, which is 750 times 0.3893 times 1 minus 0.3893 becomes 178.309, still greater than 10 too. So that check. And then also number 3, the sample size are less than 5% of the population size, which is must be true, okay? Because they're talking about the whole the population, okay? So let's start with the step 1. So in step 1, we have to compare. So we have to actually we want to determine whether the percentage of the urban household with the internet access is greater than. So the important key is the percentage of the urban household with the internet access is greater than the percentage of the rural household with the internet access. Okay, so it says the greater than. Okay, this is what we need to focus on. Erase a little bit. Okay, so I want to say this whole thing. Yeah, this greater than. Okay, all right. So H of 1, the alternative, the null hypothesis is, let's say, P1 is equal to P2, and then versus and H of 1, which is P1 is greater than P2. Or you can also say that H of 0 is P1 minus P2 equal to 0. And then H of 2 is P minus P2 is greater than 0. So either one is fine. To think about the level of significance, which is alpha is actually the equal to 0.05, which is right here. And then in step 3, we have to find the pool estimate of p hat, which is p hat is x1 plus x2 over n1 plus n2, which is 338 plus 292 and over 800 plus 750, which is 0.4065. So we're going to use this. All right, so now we need to find the test statistic. So test statistic, which is a z sub 0, which is you have to put p1 hat minus p2 hat and over and p hat times 1 minus p hat and then times by 1 over n1 plus 1 over n2. And then when you plug it in, 0.4225 subtract 0.393 over 0.4065 times 1 minus 0.465 and multiply by 1 over 800 plus 1 over 750, which is when you compute it out, I got 1.33, which is this is what I need to remember. All right, I don't have enough space. Oh, I do have a next page. Okay, it's empty. All right, so now in the next page, I want to do the classical approach. Okay, so classical approach means step 4. Okay, I know this is a right tail. with alpha equal to 0.05, and then the critical value that you need to find it from here. Okay, so we are looking for the z sub alpha, which is z sub 0.05, which is 0.05 is area of the here, and then we're looking for that z-score. So if you're looking at that z-score from the z-table, it will give you 1.645. That's a close possible, okay? But you might get the negative, but this is the right side, so I use a positive. Now, you have to check with the test statistics. The g sub 0 that we found from the previous page was 1.33. So I can see that this is going to be 1.645. In order to put the z sub 0 is going to be right here. So 1.33, right? Which is z sub 0, which is not in the critical region. So in the step 5, we have to say we fail to reject the null hypothesis. Which means there's insufficient evidence at the alpha equal to 0.05 level of the significance to conclude that the percentage of the urban household with the internet access is greater than the percentage of the rural household with internet access. All right, so there might be same. Okay, all right, now p-value approach. So you can use either one, okay, on the exam. So step 4, of course, is a right tail. So we're looking for the p-value, which is we have to put the probability of z must be greater equal to z sub 0, which is z sub 0 is 1.33. So if you're looking at the probability, and then the z is greater than 1.33, which is going to be, it's about 0.09. Okay, that's a probability, that's the area. Okay, and then step 5, you have to put the p-value, make sure the less than alpha. So p-value is 0.09, but alpha is 0.05. When you check that, which is not true, that's why we reject the null hypothesis. So now step 6, which is going to be the same, that there is insufficient evidence at the alpha equal to 0.05 level to conclude that the percentage of urban household with internet access is greater than the percentage of rural household with internet access. Okay, all right. All right, let's look at the next problem. Next things about the constructing one minus alpha times 100% confidence interval for the difference between the two population proportions. To construct the 1 minus alpha times 100% confidence interval for the difference between two population proportions, the following requirement must be satisfied. So same thing. So samples are obtained with the independent using the simple random sampling. And also this must be satisfied. also the sample must be the less than or equal to the 5% of the whole population of each case, okay? And then provided this requirement are met, so we can find the lower bound and upper bound. With the lower bound, we're using this formula, so it's a z-score of that. And the upper bound, we're adding it in, and then we just find this one, okay? All right, let's look at the next problems. So, economists obtain a random sample of the 800 urban household to find that the 338 of them internet access. They obtain the random sample of the 750 rural households, and the first find that the 292 of them has internet access. We use a 99% confidence interval for the difference between the proportion of the urban household that the internet access that the proportion rural households have internet access. Alright, so in here, we're looking for the two bounds here. So we already proved it, right? We already verified in the example 2 that same problem, right? So we already verified the requirement. And then for the construct the confidence interval for the difference between the two population proportions previous sample. So we are looking for the g sub alpha over 2. But the alpha is 1 minus 0.01, which is 0.99, sorry, so it's going to be 0.01. And then when we're looking for the g sub 0.01 divided by 2, we're going to 0.005, which is about 2.575. And also P1 hat was 338 over 800, which becomes 0.435. And P sub 2 hat is 292 over 750, which becomes 0.3893. And then the lower bound, which is P1 hat minus P2 hat and minus z sub alpha over 2 of P1 hat times 1 minus P1 hat over N1 plus P2 hat times 1 minus P2 hat over N2. And upper bound, so I want to plug it in. So 0.435. Oh, sorry, it's not true. Sorry, it's a 4225. Sorry about that. 0.4225. Subtract the 0.3893, and then g sub alpha over 2 was 2.575 and square root of, and p is 0.4225 times 1 minus 0.4225 over 800 and plus of another parenthesis 0.3893 of minus 0.3893 over 750. And then it becomes a negative 0.0310. Okay. As the upper bound, we have to add it, right? So P1 hat minus P2 hat plus g sub alpha over 2 of P1 hat times 1 minus P2 hat over N1 and plus P2 hat 1 minus P2 hat over N2. So same thing, 0.4225 minus 0.3893, but this time added it, 2.575, square root of 0.4225 times 1 minus 0.4225 over 800 plus 0.3933. Okay, so 0.3893 times 1 minus 0.3893 over 750, and then I get 0.0974. So now we have to conclude it, right? So we are 99% confidence that the difference between the proportion of urban households that have internet access and then the proportion of rural households that have internet access is between negative 0.03 and 0.10. Okay, so since the confidence interval contains a 0, interval contains 0, we are unable to conclude that the proportion of urban household with the internet access is greater than the proportion of rural household with the internet access. Okay, all right, so we can also provide the confidence interval too. So same, it comes out the same way, right? And also the next problem, determine the sample size necessary for the estimating the difference between the two population proportion within the specified margin error. So the determine the sample size n required to estimate a single population proportion within a specified margin of the error E with a specified level of the confidence. So we are using these parts, okay? And then determine the sample size when we want to estimate the two population proportion with the margin error was this one, okay? So this is for the single population proportion is going to be two population proportions. So determine the sample size necessary for the estimating the difference between the two population proportions, which is sample size is estimating the P1 minus P2. So n equal to n1 and 2, same thing. We're using these formulas, okay? But if you don't have any of the proportion available, we're using 0.5 instead, okay? So instead of using this one, we're using this one. So round to the next integer. So the margin of the error should be always expressed as a decimal with the formula 4 and then the 5, okay? All right, so let's look at up the next questions. A doctor wants to estimate the difference in the proportion of 15 to 19-year-old mother that received the prenatal care and the proportion of the 30 to 34-year-old mother that received the prenatal care. What sample size should be obtained if she wishes the estimate to be within 2 percentage point with a 95% confidence assuming? Okay, so A, she used the results of the National Vital Statistics Report results in which 98% of the 15 to 19-year-old mother received the prenatal care, and then the 99.2% of the 30 to 34-year-old mother received the prenatal care. So in order to compare, so now we know that we have E is 0.02 as a problem here, which is so the estimate within the 2% point, okay? And also Z sub alpha over 2 we need it. So Z sub alpha is gonna be the 0.95. So in order to get alpha is 1 minus 0.95, which is going to be 0.05, but divided by 2. So it's going to be Z sub 0.025, which is 1.96 that you can find it. And then we're going to say P1 head is going to be 0.98. And then another P2 head is going to be 0.992. So we are using these two percentage to compare with young mom and old mom. So now the sample size will be N1 and 2, which is same as N, right? And then we put the P1 hat times 1 minus P1 hat plus P2 hat times 1 minus P2 hat and times z sub alpha over 2 e over e to the square. So plug it in. We got 0.98 times 1 minus 0.98 plus 0.992 times 1 minus 0.992. And then g sub alpha over 2 is 1.96 over 0.02 square. And then I got 264.5. That means the doctor must sample 265 randomly selected 15 to 19-year-old mother, and also 265 randomly 32, 34-year-old mother too. Okay, what if they don't have any of the prior estimate? Okay, so the formula was n equal to n1 and 2, which is gonna be 0.5 of this alpha over 2 over e square. Okay, so 0.5, and this alpha was a 1.96 over 0.02 square. It becomes 4,802. So which is a lot bigger than what we have here, right? So which means this time the doctor must sample 4,802 randomly selected 15 to 19-year-old mother, and also another 4,802 randomly selected 32, 34-year-old mothers. Alrighty? Okay, so that's how you do the two samples for testing. Okay, alright, thank you for listening.